Hello friends, welcome back. Hearty welcome to you. Let us look at this interesting problem related to coordinate geometry, straight lines. In triangle ABC, let AD be the median and ABC. We haven't drawn the median, we'll draw that. In triangle ABC, let AD be the median and OGP be respectively the circumcenter. So O is circumcenter, G is centroid and P is the orthocenter. Then triangle OGD is directly similar to which part of this? Now we not only solve this problem, we will also try to understand what is the relation between OGP, are they collinear or not. Okay, we'll try to understand that also. Okay, fine. So first we need to prove that we need to show that OGD is similar to which one of them. So let's start with what is the information given to us. What information is given to us? Given to us that AD is the median. So let me draw the median first. Let us say that this is where we are starting and we have to go till midpoint. So this is midpoint of BC. So we have there AD. That is D. So we have AD median. Now once we know AD is the median, we have here circumcenter, centroid and orthocenter. The first thing we can easily find out is centroid, because we know that centroid divides the median in the ratio 2:1. So somewhere here I should have my centroid. So let me just go and place it there. We'll say that this particular point is G. Now let's go back and see what else they have given. They said O is the circumcenter and P is the orthocenter. Now by definition, what is orthocenter? Orthocenter is point of intersection of altitudes. So from here, if I am able to draw the altitude to BC, my orthocenter will be somewhere on this particular line only, because it's a point of intersection of altitudes. That means orthocenter should be a point on this altitude also. So let me just go ahead and draw that altitude. So we'll draw an altitude from A. Let us say this is the altitude we are talking about. And when it is altitude, we know that obviously that line is perpendicular to BC. So this is altitude. Okay. Now we have drawn one altitude. Now let us see next what we have. Circumcenter. So we understood that this is the centroid and we know that orthocenter will be a point on this. We don't know where it is. Similarly, what is circumcenter? Circumcenter is point of intersection of perpendicular bisectors. Already we have median here. AD is the median, that means D is midpoint of BC. Perpendicular bisector is a line which divides the given line segment into two equal parts, and also it is at 90 degrees. That means that line is also perpendicular to BC. So through D, let us try to draw the perpendicular bisector. So this is my perpendicular bisector. I'll just this is the perpendicular bisector we have, and we know that that is at 90 degrees. Let's put some alphabets there so that there is no confusion. Let us say this is X and this is Y. Now what we are saying is very simple. We are saying that AX is perpendicular to BC because it's an altitude. Similarly, dy is perpendicular to BC because it's a perpendicular bisector. It should be at 90 degrees to BC. This tells us that AX is parallel to dy. That is interesting. Now we got two parallel lines, and remember, whenever there are parallel lines, there is always a scope of having similar triangles. So let's go ahead with that. With whatever the work we have done, we know that orthocenter will be a point on this and circumcenter will be a point on this. So let's just go ahead and take some points there and we'll say they are, let us say this is this point is our circumcenter. Circumcenter is O. So this is O and this is P. Let us join OGP. So we joined OGP. Now you can see that we have one triangle OGD here. Another triangle is AGP. Remember, we have parallel lines. Whenever we have parallel lines, we have alternate interior angles. So we have this angle equals to that angle, and we also have vertically opposite angles. So let's write down the triangles which are similar to each other. The first triangle they have given is triangle OGD. This is D, similar to. Now G to G, so it will come in second position, and D is to A, so we'll have A in the third position. Left out is P. So the triangle which is similar to OGD is triangle PGA. Not only that, since we know these two triangles are similar to each other by AA similarity criteria, why can't we write down the corresponding sides which are in proportional? Let us see what happens now. We have OG divided by GP is equals to GD divided by GA. We can write it as AG, which is also equals to OD by AB, but we'll ignore that. And we know what is this GD by AG, because we know that the centroid divides the median in the ratio 2:1. So this is 1 by 2. That means we know that the centroid divides also the orthocenter, the circumcenter and the orthocenter in the ratio 1:2. The centroid divides the circumcenter and the orthocenter in the ratio 1:2. So that's a key takeaway we can take from this problem, that we know that OGD is similar to PGA. Not only that, we also learned that OGP are collinear, and actually G divides OP in the ratio 1:2. That is OG by GP equals to 1 by 2.